Alright guys, let's settle in. How do we get to the... No.
Oh, we should play Yahtzee. I like that idea.
We should do it.
We did that on Friday.
You should have finished. You had a little over a period, right? Alright. Periodic table. Write down the periodic law, please. While I go blow my nose.
I will search, don't you worry.
What day is your Marty's birthday?
I don't like that.
27.
Wait.
No.
I'm old. Birthdays don't count when you get old.
March of 70.
71. Alright, periodic law states that the periodic table, which you have in front of you, has certain patterns. Those are called periodic functions. Pattern after pattern after pattern reoccur on this periodic table. And it is also based on the atom's atomic number. So properties of elements are periodic functions of their atomic number. Now, there was a guy. Here we go with the dudes again. Okay? His name is Dmitri Ivanovich Mendeleev. And Big Dmitri started to arrange the 60-ish elements that he knew about and started to categorize these elements and put them in some sort of order. There were other scientists that also did the exact same thing, but they did not get credit for it. And the reason why they didn't get credit for it is because Dmitri did one little thing that the other guys didn't do. And that is, once he arranged these elements in order, he realized there were spaces on the periodic table where there should have been an element, but that element had not been discovered yet. And so he said, I'm going to look at these elements and I'm going to predict an element is going to be found in the future and it is going to fit in this spot based on the properties of the elements that are around it. So if all the elements around it were shiny, he said the element that fits here will also be shiny. And if it had a high melting point, he said it has a high melting point. If he saw that you had elements that were like 50 grams and 70 grams, he said the element that's between those two should be about 60 grams. And because of these predictions that he made, and it turned out that a French scientist actually found one of the elements that he predicted would exist, he was given credit for inventing the periodic table. That's why he got the credit. Not because he arranged them, because there were lots of scientists that arranged them. He arranged these elements according to atomic mass. That is not what they are arranged by today. They are arranged by atomic number. Okay? Any questions on that?
No.
Alright, let me stop this video, even though I didn't really say too much yet. Can I keep going? And he gave us this lovely periodic table. Now, there's a lot on here, and I understand there's a lot on here. The first and simplest thing that we're going to look at on this is where the metals are located, the nonmetals, and what we call the metalloids. Alright, first thing, look at your periodic tables in front of you. You see that black line that kind of goes between boron and looks like a staircase and it goes all the way down? Do you see that? Okay. That separates the first half and the second half of the periodic table. I know they're not exactly halves, but just bear with me. So the left side of the periodic table, anything to the left of this to this staircase. These are classified as our metals. You're going to get a periodic table to write all this stuff down on. I'm just giving you the bare bones right now. Some of these metals you might recognize, like copper and nickel and iron and tin, wherever the heck tin is. Here's tin. And silver and gold and platinum. These are the metals we think of when we talk about metal. Even aluminum is a true metal. But these guys over here, in the first column and the second column, are also metals. When I say to you calcium, what do you think of?
Milk.
Milk and bones. Bones are not metal. Elemental calcium is a metal. Bone is made out of a compound of calcium and something else. So these are still metals. Now there's one element on the left side of the periodic table that is not a metal, and that is hydrogen. Not a metal. It's a non-metal that found its way over here. Okay? So most of the elements on the periodic table are going to be your metals, and they are located on the left side of the periodic table. From what we know so far, what else can you tell me about these elements that are over here on the left side? Think about what their electrons do. Do they like to gain electrons, or do they like to lose electrons? They like to lose electrons. So these are the losers. They live on this side of the periodic table. They're going to lose their electrons very easily. That's what's making them a metal. Alright, the nonmetals I have all here in pink. So these are all your nonmetals. Things that are like oxygen, or fluorine, or neon, or argon, or chlorine. These are our non-metals. And then in between the nonmetals and the metals, you have these that I have marked in orange. They separate the metals from the nonmetals. These are called semi-metals. They are halfway between metals and nonmetals. They have properties of both metals and nonmetals. And what do I mean by properties? So, what are some physical properties of a metal?
They're like strong.
Okay, there's some strong things over here too. They are conductors. They are excellent conductors of heat and electricity. You're going to write that down in a second. What else do we know about metals? Say it again. Some of them are dense. Some of them are more dense than others. Like lithium is a very light metal. Aluminum is a very light metal. But if I give you lead, it's a very dense metal. So I wouldn't put that down as a property. Give me something that you can see about a metal or feel. They are shiny. Now, we have a fancy word for shiny. Luster. Very good. They have luster. So they have luster. They are, did you ever hear the word malleable?
Yes.
Okay, what does that mean?
You can like bend it.
You can bend it. So if I give you a piece of aluminum foil, you can make that aluminum foil into a beautiful swan, right? Or you can make that aluminum foil into a dog or a cat or whatever animal you want it to be. It can be shaped very easily. They are bendable. They are malleable. Do you know what the word ductile means? Okay. Ductile means you can make it into a wire. So they heat up the metal so it gets red hot, and then they pull it, and they get this long, skinny strip of metal in between. That's ductility. All right, so here are some of my properties of metals. Luster, which means they are shiny. Ductile, which means that they can be made into a wire. Malleable, which means you can shape them, or they're bendable. They are good conductors of heat and electricity, and they have high melting and high boiling points, which is really good because if we're building a bridge out of something and we have a really hot day, we don't want the bridge to burn or to melt. So they have high melting and high boiling points. There is one or two metals that are going to have lower melting and boiling points. One of them is mercury. Mercury has a low melting point. That's why it's a liquid at STP. STP means standard temperature and pressure. Let's write that down. I want you to think of standard temperature and pressure as being what you are sitting at right now. Normal. Standard. There are numbers that are associated with it, but for your purposes, standard is normal. We're not heating it up, we're not cooling it off. We're not putting it under pressure or we're taking the pressure off. Okay? So there are a couple of metals that will have lower melting points, but for the most part, they are high melting points. Alright, I'm assuming we're getting close to the end.
Yeah,
Okay. What's that? Yeah, gallium. Gallium is eka-aluminum, and eka-aluminum is the one that Mendeleev predicted the properties of. Gallium melts at a very low temperature. You could hold it in your hand and it just turned, yes. So